There is a place on the map that historians call the beginning, the land between two rivers, the birthplace of writing, of law, of cities, of kings. For thousands of years, the story of Mesopotamia has been told as an origin point, a single cradle from which civilization rose, fully formed, into the world. But origin points are rarely that simple. When geneticists finally turned their instruments toward the ancient Near East, they were not looking to overturn a myth. They were looking to confirm one. What they found instead was a population history so layered, so contested, and so quietly complicated that it forced a reconsideration of what Mesopotamian ever meant in the first place. Because the people who built the world's first cities were not one people. They were several. And the genome remembers what the history books simplified. For generations, the accepted picture was straightforward. Mesopotamia, modern-day Iraq and parts of Syria, was home to the Sumerians, then the Akkadians, then the Babylonians and Assyrians, a succession of civilizations rising and falling along the Tigris and Euphrates. Historians traced this through cuneiform tablets, king lists, and the layered ruins of cities like Uruk, Ur, and Nineveh. Linguists noted that Sumerian itself was a language isolate, unrelated to anything else known, while Akkadian belonged clearly to the Semitic language family. The assumption, reasonable at the time, was that these were successive waves of a single regional population, occasionally joined by outsiders, but fundamentally continuous. One river valley. One long, unbroken story of settlement, innovation, and empire. It was a clean narrative. It explained the archaeology. It explained the texts. And for a long time, there was no way to test it against anything deeper than pottery and script. Then came the first cracks, long before DNA entered the picture. Sumerians' total isolation as a language bothered linguists for over a century. If the people of southern Mesopotamia had simply emerged locally, why did their language share no known roots with any neighboring tongue? Archaeologists also noticed something strange in the material record: sudden shifts in architecture, in burial customs, in the layout of early cities, that did not always align neatly with gradual, local development. Something about this single continuous population model felt too smooth, too convenient, as if history had been sanded down to fit the story we wanted to tell. Researchers began asking a quieter question. Were the builders of the first cities descended from a single regional population, or did the miracle of early civilization sit at the meeting point of several very different peoples? This is where the science had to catch up to the suspicion. Ancient DNA analysis works by extracting genetic material preserved in bone and teeth, then comparing ancestral markers across time and geography. Mitochondrial DNA traces the maternal line. Y chromosome DNA traces the paternal line. Autosomal, whole genome data reveals the broader mixture of ancestry a person carries from all their ancestors combined. Applied to ancient skeletons, this technology allows scientists to ask a question no clay tablet ever could: not what did these people believe about themselves, but who were they, biologically, and where did their ancestors actually come from? But Mesopotamia presented a problem almost immediately. The very thing that made the region so fertile, the heat, the humidity, the seasonal flooding of the Tigris and Euphrates, is catastrophic for the survival of ancient DNA. Genetic material degrades quickly in warm, wet conditions. For years, the cradle of civilization remained, ironically, one of the hardest places on Earth to genetically sample. Researchers remain cautious here, because the ancient genomic record from the region itself is still thin compared to cooler regions like the Caucasus or the Iranian Plateau. So scientists did something clever. Rather than relying solely on remains found within Mesopotamia, they expanded outward, sampling ancient populations across the wider Fertile Crescent, from the Zagros Mountains of Iran, to the Levant, to Anatolia. If Mesopotamian civilization sat at a crossroads, then the ancestry of the people who built it should be traceable through the populations that surrounded it. That was not a contradiction of the old story. It was a signal. What the data began to reveal was that the Fertile Crescent was never home to one ancient population. It was home to at least 3 genetically distinct groups in the millennia before cities existed: early farmers of the Zagros Mountains, early farmers of the Levant, and early farmers of central Anatolia. These populations had diverged from one another for thousands of years, developing independently, separated by mountains and distance, before agriculture eventually pulled them back into contact. And when contact happened, it did not happen
quietly. If you enjoy this kind of science-driven history, where the evidence keeps rewriting the map, consider subscribing, because almost nowhere in the ancient world turns out to be as simple as the textbooks suggested. The genetic data increasingly suggests that the population of ancient Mesopotamia, and Sumer in particular, carried ancestry from more than one of these ancient streams. Researchers have proposed several explanatory frameworks to account for this, and none of them has been fully settled. One possibility is straightforward admixture, that as farming spread and trade routes opened across the Fertile Crescent in the Neolithic period, Zagros-related, Levantine-related, and Anatolian-related populations gradually mixed in the lowlands of southern Mesopotamia, producing a genetically blended population well before the first cities appeared. Under this model, Sumerian civilization was not built by outsiders arriving to a blank landscape. It was built by the descendants of a fusion that had already been underway for centuries. A second possibility involves what researchers sometimes call a ghost population, a genetic contributor detectable in the ancestry of later peoples, but not yet directly sampled in the ancient record. Some analyses of Mesopotamian adjacent populations hint at a deep ancestral component that does not cleanly match any of the three known Fertile Crescent farming groups, suggesting an additional, still poorly understood population contributed to the mix, one whose remains have not yet been recovered or sequenced. A third framework centers on later contact events. Even after the initial Neolithic mixing, the historical record shows repeated waves of movement into and out of Mesopotamia, Semitic-speaking pastoralist groups from the Arabian periphery, highland populations descending from the Zagros, and connections stretching toward the Caucasus and the Iranian plateau. Each of these could have layered additional ancestry onto an already blended population, meaning the Sumerians and Akkadians of the historical record may represent not two separate peoples, but two names layered onto a single, continuously mixing population, distinguished more by language and political identity than by biological descent. Researchers are careful not to declare any one of these frameworks the final answer. The honest position, and the one taken by most geneticists working in this field, is that all three processes were likely happening simultaneously, over a very long span of time, in a region that functioned less like an isolated cradle and more like a crossroads. This is where the landmark research becomes important. Broader ancient genome studies across the Near East, expanding sample sizes, comparing early farmers to later Bronze Age individuals, and modeling ancestry proportions with increasingly refined statistical tools, have shown that Bronze Age Mesopotamian region populations already carried a mixture of Zagros-related and Levantine-related ancestry, with additional signals pointing toward exchange with populations further east and north. This was not a minor academic footnote. It reframed the entire model of how the region's population came to exist in the first place. The old story imagined a lone river-valley civilization, gradually improving itself in isolation. The genetic evidence points to something else entirely, a landscape where migration, trade, and mixing were not exceptions to the story of civilization. They were the mechanism of it. Here is the twist that reframes everything. The rise of the world's first cities did not happen because one unified population finally reached a tipping point of local innovation. The evidence increasingly suggests that early Mesopotamian civilization emerged at the genetic and cultural intersection of separate ancestral lines, mountain farmers, lowland farmers, and possibly a still unidentified contributing population, meeting in a river landscape uniquely suited to large-scale agriculture and trade. Not one people building alone. Several ancestral lines converging, in one of the only places on Earth where geography made that convergence sustainable at scale. This does not diminish the achievement of early Mesopotamian civilization. If anything, it deepens it. Writing, law, irrigation, urban planning, and organized religion did not emerge from a single, self-contained population working in isolation from the world around it. They emerged from contact, from the friction and cooperation of genetically distinct human lineages forced, by geography and opportunity, into shared cities, shared irrigation systems, and eventually shared language and administration. This matters far beyond Mesopotamia. It reflects something true about nearly every population geneticists have studied in depth. Human history is not a story of pure, isolated lineages slowly perfecting themselves in place. It is a story of movement, of contact, of populations.
Meeting, mixing, separating, and meeting again across thousands of years. The idea of a single, unbroken people occupying a single homeland since time immemorial rarely survives contact with the genome. Mesopotamia, so often held up as the purest example of a civilization rising from one soil, turns out to be one of the clearest examples of the opposite. Picture the landscape itself for a moment. The flat, wide floodplain between the Tigris and Euphrates, the horizon broken only by the mud-brick silhouettes of ziggurats rising out of the haze. To the east, the blue wall of the Zagros Mountains, home to some of the earliest farmers on the planet. To the west, the dry hills rolling toward the Levant and the Mediterranean coast. To the north, the plateaus stretching toward Anatolia and the Caucasus. Mesopotamia was never a closed room. It was an open floor at the center of the ancient world, with doors leading in every direction, and for thousands of years, people walked through all of them, carrying their languages, their tools, their gods, and their ancestry with them. It is easy, standing at a distance of 5,000 years, to imagine the first cities as a single triumphant beginning. It is harder and more honest to imagine them as a meeting point, a place where different human lineages, each carrying its own deep and separate history, arrived at the same river system and discovered that together, they could build something none of them could have built alone. The DNA does not erase the achievement of ancient Mesopotamia. It relocates the miracle. The miracle was never a single people rising in isolation. The miracle was convergence, different ancestries, different origins, meeting in one place and choosing, again and again across centuries, to build a shared world together. The tablets recorded laws, harvests, and the names of kings. They did not record the deeper layers of ancestry carried quietly in the bodies of the people who wrote them. That record waited in the ground for thousands of years, waiting for a different kind of reading. The map we were taught was not wrong so much as incomplete. It described where cities stood, not where the people who built them had truly come from. And every time the genome adds a new layer to that picture, the story of civilization becomes not smaller, but larger, a reminder that the places we call cradles were rarely quiet and rarely alone. If this kind of story interests you, where the ground itself turns out to remember more than the history books ever could, let me know in the comments which ancient population you'd like uncovered next. The genome is still writing its own record of the human past, one layer at a time.